Hi, my name is Megan Delaney, and today I'm going to be presenting on double and triple integrals. So for problem A, evaluate the given integral by changing to polar coordinates e raised to the negative x squared minus y squared dA, where d is the region bounded by the semicircle, x equals the square root of 81 minus y squared and the y-axis. So to start off, we're going to write our bounds, which is going to be negative pi over 2 and positive pi over 2. And 0 and 9. So now we're going to have our bounds. And then e to the negative r squared r dr d theta. So now we're going to separate the two. And it's going to become negative pi over 2 d theta, and then 0, 9 re to the negative r squared dr. So when we integrate, we're going to get theta, and then the bounds negative pi over 2 and pi over 2, and negative 1/2 e to the negative r squared, 0 and 9. So for this one specifically, we're going to get pi over 2 minus negative pi over 2, which when we do that, we're going to get pi. And for here, we're going to do negative 1/2 e to the negative 9 squared minus e to the 0. So for here, we're going to get negative 1/2 e to the negative 81 minus e to the 0. So together, this becomes pi negative 1/2 and then e raised to the negative 81 minus e to the 0. So when you pull out the negative, we are going to get pi over 2 and then parentheses 1 minus e to the negative 81 as our answer. So that completes problem A. So now for problem B and our triple integral, we're going to evaluate 4x dv, where e is bounded by the paraboloid x equals 5y squared plus 5z squared, and the plane x equals 5. So first, by using polar coordinates, we're going to have y equals r cosine theta and z equals r sine theta. So then we have our triple integral 4, and then our bounds. We're going to have 5y squared plus 5z squared and 5. We get this from the original part of our problem. X dx and then dA. So when we integrate, we're going to get 4, the integral, 1/2 5 squared minus the quantity of 5y squared plus 5z squared, quantity close, squared, dA. So the reason for squaring is because the integral of x is 1/2 x squared, which is why we have 5 squared and the quantity of 5y squared plus 5z squared, squared. So when you take 5 squared times 4 and divide it by 1/2, we're going to have 50, and then the bounds of 0 to 2 pi, and then bounds to 0 to 1, 1 minus r to the 4th r dr d theta. So this now becomes 50, 0 to 2 pi d theta, and 0 to 1 r minus r to the 5th dr. So for this part of the problem, we're going to get 50, 2 pi minus 50, and then 0, which obviously 50 times 0 is 0, so then we end up getting 100 pi. So as for this part of the integral, when we integrate, we're going to get 1/2 r squared minus 1/6 r to the 6, 0 and 1. So when we input these, we're going to get 1/2 1 squared minus 1/6 1 raised to the 6 minus 0. So 1/2 times 1 squared minus 1/6 1 raised to the 6 is going to be 1/3. So together this becomes 100 pi times 1/3, which becomes 100 pi over 3 is our answer. That concludes problem B in my presentation. Thank you.